Thank you, everyone, for joining us at Griffith Observatory for a live broadcast of the southernmost moon. This kind of thing only happens over a 2-year period of 18.61 years or so. I'm Dr. Ed Krupp, Director of Griffith Observatory, and this cheering and unusual astronomical event is part of a 2024-2025 campaign to follow the greatest monthly excursions of the moon, and it is brought to you by Griffith Observatory, Griffith Observatory Foundation, and the City of Los Angeles Department of Recreation and Parks. Griffith Observatory cameras are now targeting this view of the southeast horizon from below the observatory's South Promenade and East Terrace. And in a short time from now, the moon will rise on this line just about as far south as we ever see it. The waxing gibbous moon, just a day and a half from full, will appear over that ridge at about 7:15 p.m. Pacific Daylight Time. It's still daylight here in Los Angeles, and that makes it harder to catch the moon. But the Griffith Observatory live stream broadcast team is prepared to bring it to you. The broadcast team includes Patrick So, Observatory Theaters Manager, Matthew Burlando, Production Engineer, Vanessa Alarcon, Observatory Astronomical Observer, Digital Communications Coordinator Pixie Iwata, Production Assistant Ella Ritz, Camera Operator Jennifer Wong, and Stage Manager Michael Noble. Well, the slides that we have when we first broadcast the southernmost moonrise last month begin to appear here on the evening of June 21st. And then in the early morning of June 22nd, we moved to the west side of the Griffith Observatory to the Major Standstill southern moon set line inscribed on the lower west terrace. And we broadcast from there the southernmost setting moon. The moon hasn't risen and set this far south in more than 18 years, and the moon's orbit is now tilted at the greatest angle outside the path of the sun. Those white disks represent the moon on its path, and the other circle is the sun's path. Now, on the ground, this means for the next year and a half, we'll see the most northern and southern moonrises and moonsets the moon ever reaches, and this time is called the Major Lunar Standstill. Here again is our Major Standstill Moonwatch view. The southernmost moon will appear with the illuminated line on the pavement. And here's an alternate view from Griffith Observatory's South Promenade. We'll also catch the moon rising in the archway. Now, the greatest excursions of moonset are marked on Griffith Observatory's lower west terrace, along with the solstice and equinox sunsets and moonsets when the monthly excursion is least, at minor standstill. Here, the gray lines for the northern moon's inner and outer limits flank the gold line that points northwest for summer solstice sunset. And the most northern and southern moonsets last happened in 2006, when the observatory was still under construction for renovation and expansion. The stone for the line had not yet been placed into the pavement, and this is, in fact, the Major Standstill northern moonset on January 28, 2006. Now, between now and around December 2025, the moon will reach each month, and it will rise as far north and set as far north, and rise as far south and set as far south as it ever can. And although we call this period the Major Lunar Standstill, the moon doesn't really stand still. Its monthly excursions just reach roughly the same maximum limits each month for about 2 years. The sun does something similar and does it over the course of the year. In this illustration of the sunrise limits on the eastern horizon, the June sun is rising on the left as far north as we ever see it. 6 months later, in December, it rises at its southernmost limit on the right. To the unaided eye, the position of sunrise and sunset at these times of year does not seem to change for about 3 days. The sunrise and the sunset seem to stand still, and the time when this happens is called the solstice, which means sun still. Well, the Griffith Observatory cameras are still targeting the southeast horizon, where the southernmost moon is still expected to rise. If we think of the sky as a hemispherical screen, like a planetarium dome, we can imagine how the sun, moon, planets, and stars all rise somewhere from the eastern half of the horizon on the near side in this view, then climb up the sky to their greatest height, and then head back down to the western half of the horizon, on the far side of the dome. The celestial objects all rise and set like this because the Earth is spinning on its axis, and that makes the sky seem to turn around the North Celestial Pole, a spot directly above the Earth's North Pole. Well, if that were all that moves, the sky would be simple. But other objects like the sun, moon, and planets also all move around the sky on their own paths at different rates. The sun's path through the sky is called the ecliptic, and it's just a reflection of the Earth's orbital motion around the sun. Sun takes about 365 days, a year really, to complete its circuit, and the tilt of the sun's path shifts the sunrise and sunset from north to south and back to north again in a year. Each month, the moon circles the Earth in 27 days, and the tilt of the moon's orbit guarantees the moonrise will migrate from north to south and back to north again in that time. So the moon does in about a month what the sun does in a year. It moves from north to south and back again, but the moon does something else. The moon's monthly limits gradually change. Over 18.61 years, the moon's limits move from outside the sun's limits to inside the sun's limits and then back outside the sun's limits again. The moonset lines on the lower west terrace of Griffith Observatory make this obvious. The northern inner and outer limits flank the summer solstice sunset line that points to the northwest, and the southern inner and outer limits flank the winter solstice sunset line that points to the southwest. When the moon rises and moon sets reach these limits, the limits don't seem to change much from month to month, and these periods are the standstills, one at the moon's inner limits and another at the moon's outer limits. The moon's limits still change through these periods, but the change from month to month is small, just as the daily change of the sun's position at the solstices is small. And that's why we call the moon's limits the lunar standstills. Well, we're now in the season of major standstill, the time when the moon's monthly limits are far outside the sun's annual limits. The extreme moonrises and moonsets are farther north and farther south than the solstice sunrises and sunsets. In another 9.3 years, the limits for the moonrises and moonsets will be inside those solstice points and will be at the minor standstill. And the monthly limits will then gradually increase again, and in 2042, we'll have the next major standstill. So mark it on your calendar. Well, the moon behaves this way for two reasons. First, the moon's orbit is tilted a bit compared to the Earth's orbit around the sun. And second, thanks to the gravitational pull of the sun, the moon's orbit swivels. That changes the angle of lunar excursion and the amount of the moon's reach. This Fisk planetarium animation shows how the rotation of the moon's orbit changes the angle at which we see it. These edge-on views of the Earth and the sun and the moon show how the moon's orbit flips from greater angle to a smaller angle, greater angle, smaller angle, back and forth again, and all with respect to the sun. Although the varying limits of moonrise and moonset are noticeable over time, most people, including professional astronomers, have no experience with this aspect of the moon. You have to track the moon systematically, month after month, for several years to realize the moon is doing this. And you would have to track it for several 18.61-year cycles to see and understand the full pattern. And that's what we're doing at Griffith Observatory tonight. Okay, we're still several steps ahead of the major standstill southern moon, which will show up soon on that southeast horizon. Despite the difficulty in mastering the lunar standstills, some investigations of archaeological monuments, particularly Stonehenge, have led some investigators to propose that lunar standstill alignments were designed into some ancient and prehistoric sites. In the 1960s, C.A. Newham and astronomer Gerald S. Hawkins identified lunar standstill alignments in the Station Stones rectangle at Stonehenge. The rectangle enclosed the main circle of stones and was constructed earlier and perhaps about 4,500 years ago. The long sides of the rectangle coincide with the directions of Major Standstill Southern Moonrise and Major Standstill Northern Moonset. Here is the view to Major Standstill Southern Moonrise, and here is the Stonehenge Station's view to Major Standstill Northern Moonset. Hawkins also proposed sight lines between certain gaps in pairs of archways formed by the large sarsen stones erected perhaps 500 years later. This pair of openings accommodates the Major Standstill Northern Moonset. Now, Stonehenge was not the first prehistoric monument assigned a Major Lunar Standstill alignment. In 1908, British naval officer Boyle Somerville published a Major Standstill Northern Moonrise line for the Callanish stones in Scotland's Outer Hebrides. In the 1980s, Gerald and Margaret Ponting instead favored an alignment to the low southern moon, indicated in this plan of Callanish, and here that transiting moon hugs the horizon in June 1987. The late Aubrey Burrell was a leading expert on prehistoric stone rings, and he identified Major Standstill southern moon alignments in the recumbent stone rings in northeast Scotland. This is the view to the southwest from the center of the Castle Fraser stone circle. The big recumbent stone operates like a stage across which the southern moon dances in the right standstill season. Jack Eddy, a solar astronomer, spotlighted a 2,000-year-old Major Standstill Northern Moonrise alignment with the axis of the prehistoric Hopewell Circle and Octagon mounds at Newark, Ohio. And Stephen Patricio reconstructs here Newark's Major Standstill Northern Moonrise. An ancestral Pueblo great house, about 1,000 years old, at Chimney Rock National Monument near Pagosa Springs, Colorado, accompanies the restricted view of the Major Standstill Northern Moonrise framed by the distinctive rock pillars. Some believe the great house was built on this demanding mountain ridge to accommodate the northernmost moon in the Chimney Rock Gap. Griffith Observatory astronomical observer Vanessa Alarcon photographed the northernmost moon here last October, and Dr. Amanda Bosch of Lowell Observatory caught last December's full moon at Chimney Rock right here. Well, deliberate inclusion of lunar alignments in ancient and prehistoric monuments has not been proved and remains questionable. Griffith Observatory, on the other hand, possesses intentional lunar alignments, and throughout the rest of 2024 and most of 2025, Griffith Observatory will broadcast selected moonrises and moonsets at the moon's maximum excursion. We are now about to broadcast live the Major Standstill Southern Moonrise from below the observatory's south promenade along a moonrise line installed in the southeast loading zone and headed southeast over Elysian Park, Santiago Peak, and on to Palomar Mountain. The moon may be standing still, but Griffith Observatory never stops moving. Ladies and gentlemen, we're about 3 minutes from the official time of moonrise, when the moon will rise as far south as we see it in the course of its entire history of going around the Earth. Now, it does that every 18.61 years or so, so it's not like this is the first time in 4.5 billion years the moon has done this, but in fact, it's just about the first time that we've had a chance to see it here at Griffith Observatory. We broadcast this event a month ago successfully, and over the course of the next year and a half or so, the moon each month will reach its northern and southern extremes, and as it does that, we'll select particular moon rises and moon sets as public events and as live stream events, and we're live streaming this event to the world right now. The moon does all of this simply because of gravity, and we're all very grateful for gravity, except when I trip on the tables in the house or something like that, or the dog gets in the way. But in fact, it is the influence of gravity on the moon's orbit that causes it to swivel around. As the moon orbits the Earth, its orbit also moves, and that shifting of the moon's orbit changes the angle of the orbit with respect to the Earth and the sun. And through that, the angle of the moon changes its position on the horizon, which is why we get these variations in moonrise and moonsets over this long period of time. The moon's position is always changing like this. It's really complicated, and it's hard to figure out how anybody actually managed to do it. You have to watch the moon for a long time, multiple generations, to get this thing down. But at Griffith Observatory, we've had the generations. We've got it down, and you're about to get it down as well. The moon should rise right over that ridge out there. You can see where the line is headed, but we can't predict exactly when that's going to occur. We've got a couple of other effects in place. Atmospheric extinction is one of those. We live in an atmosphere that just diminishes the light from celestial objects. And you might think that astronomers are really annoyed by that, but they like to breathe too, so it kind of works out. But the atmospheric extinction will diminish some of the light of the moon, and there does appear to be a layer of that strange substance of Southern California kind of lying like a gray blanket out there. But nonetheless, once that moon, fairly bright, makes its appearance, it should show up. Now you can see I'm constantly looking over there, worrying that I'm missing it, but probably somebody else will catch it before I do. But I'll pause for a moment. We'll give the moon a chance to rise. And here's a primary rule of astronomy. You must be patient. The moon's going to do what it's going to do, and we cannot make it move faster. For those of you who are really dedicated, we are broadcasting the moon set from the West Terrace early tomorrow morning, about 4:25 a.m. So you can't come on the grounds. The park is closed, but you can go back to your computer and tune in to us. We'll be up there, ragged, of course, for being up all night. Clock says it's 7:12 now, official time of moonrise. The moon ought to be appearing almost any time, depending on what it has to encounter coming up. Of course, there's always a chance the moon won't come up. And then we shall spiral out of our orbit and into the sun and be consumed. Go Moon. So while we're waiting for the moon, I'm going to be listening to each of you telling me the title of a song with moon in it. Just- Red Moon Rising. I'll repeat them. Moonlight Sonata. There was Moon River. Fly Me to the Moon. Harvest Moon. Sail On, Silvery Moon.
Claire de Lune.
Claire de Lune is a good one.
Bad Moon Rising.
Bad Moon Rising, excellent. Is that a little Creedence Clearwater on there?
Yeah. Moon Shadow.
Moon Shadow. I've seen lists of them. There are hundreds. Dancing in the Moonlight.
The Dark Side of the Moon?
That's a whole concept.
There's a song.
It is. It is.
There's a song.
It's a whole album.
Hijo de la Luna.
Yeah.
Anyone in other languages?
They won't be back there for the
If it's any comfort, the software on my phone tells me it's right there. It would be very troubling if it weren't. It would mean that we calculated everything wrong.
you can see it. So we can actually see it. So
I've got it full orb on the horizon, so I suspect it's just wrestling with the smog.
see it. No, we can see it. Oh, oh no. You just look and you like your eyes like you get slowly focus a bit and you see like the color difference. Maybe you're just not wearing glasses. I just want it to be more lit. It's kind of like it's to the right of the
Oh, yeah, got it. Okay, so we're looking for that building here. So it's around here. That building right there. That one.
The tiny two buildings, yes. Right on top of that, you can see the circle. You see the edges shaping up.
Dr. Krupp, can you see it?
Not yet.
Can you see it?
Yeah.
Where is it?
So to the left of the beige building.
Right in between the two people right now.
Yeah.
I see. Actually,
Yeah. Working for me yet. Yeah. Good. Are we getting it in camera? I think I'm seeing that. Yeah. It's still difficult with the bright sky.
now it's way clearer.
the full circle very well.
See that bench? It's up the left. To the left.
Oh yeah.
Oh.
Yeah.
I lost that.
No, it was lower than that.
Yeah.
Now it's more white. A minute ago, now it's really cool.
You see it? High. High above there, right?
Yep.
Right there.
Should come into view for just about everybody by now.
Although my camera can't pick it up, but we're looking at it.
About 3 diameters of the moon above the horizon.
Yeah.
So let's check in with you. What's your question?
I'm okay to go to downtown now and focus on that.
Maybe. I'm not sure what else is happening here.
Okay.
So right now what we have is 2 looking out at the moon.
So, ladies and gentlemen, you are all, in fact, pilgrims of the Major Standstill southern moon, and you are key witnesses to one of the most important facts of the day. Griffith Observatory doesn't lie.
Okay.
Shit is picked.
Yeah, gotta be very.
Each minute, and I was just like,
Sorry?
But again, there's so much.
Senin yarım saat kaldı.
So this is like the maximum then. So the moon usually isn't there. Okay. So what's so special about like today? I'm looking to. Oh, okay. Gotcha. Wow. Wow. Okay. Well, where's it like usually like? Right. Day by day, I'll start going this way. So we're looking south, right? Okay. Gotcha. So it's on at 18 years. Cool.
Thank you, Dr. Krupp. Thank you. Nice to see you. Thank you, everybody.
How could they have seen it before?
That was the best chance you're going to get to show them. It was a shot you took. This looks like a job.
Thank you for joining us for the Major 7 Moonrise. We are going to present some views of the moon accompanied with planetarium music. So enjoy the view, and we'll see the views of the moon as it ascends into the sky and becomes a little bit more clearer than we can see now. Thank you for tuning in to our live broadcast of the Major Standstill 7 Moonrise. Tonight the moon rose at its farthest south on the horizon, rising at 7:12 p.m. Pacific Daylight Time. It will continue to ascend, reaching 27 degrees above the southern horizon by 11:58 p.m. tonight, at its lowest altitude as seen from Southern California. Please join us for our next broadcast at 4:25 a.m. Pacific Daylight Time tomorrow to observe the moonset, We extend our gratitude to Griffith Observatory, Department of Recreation and Parks, City of Los Angeles, and Griffith Observatory Foundation for making this broadcast possible. Have a pleasant evening and until tomorrow morning.